Hello again, this is Mark Summers from Summers Technical Services. We're going to continue on with our waveguide assignment, and we've successfully built our waveguide part. Now we've got to build the flange part, and this part is going to be a cylindrically shaped part, so it makes sense to use a revolve command for this first feature. And we've got some holes and some cutouts to make, so we'll do all those features and see if we can't make this thing. So let's get started. Alright, as before, we'll start with a new part model. We're doing inches, so we'll use our typical part model template, and I'm going to think about this part revolving around that right plane. That makes sense, is going this way. So that seemed like a good choice. So I'm going to sketch and make my sketch to be revolved. What happened? Now we're rocking. Alright, so my center line is going to be a horizontal line here going through the origin. And so wait for it. Need my boss to buy me a new computer. I forgot I am the boss. Alright, buy a new computer, Summers. Alright, here we go. Here's the center line. I want it to go through the origin. As usual, I want to make it infinitely long, because that's the way I roll. Needs to tie to the origin. Alright, now maybe I'm ready. So we're going to draw half of it. I can't put a hole in the middle because that hole is going to be rectangular. So I want to close this thing out. It's going to look, this is the front face. I want the front face to be on the front plane. So this goes up like this. This goes down a little further. And that doesn't look too horrible. Alright, so now I've got a bunch of verticals and horizontals. I think I'm ready for some dimensions. And I don't dimension to the edge, I dimension to the center line so I can get all these in diameters. And so that diameter looks like to be a 1/2 inch. This diameter looks to be 4685. Seems to be a weird number, but it is what it is. And then this is 1 1/8. Alright, now we need to do some horizontal dimensions. This one is 130. And the overall is 1/4. Easy peasy. And this is 032. Or 1/32 for the decimally challenged folks out there. Alright, looks like I'm fully defined. Why does it say underdefined? Where's my blue? I don't see any blue. I think it's lying to me. Let me get out of the sketch. Sure enough, it rebuilt itself, so it's actually constrained. Sometimes SolidWorks needs a little shove there. Alright, so I got my sketch. Let's revolve this bad boy. Select the sketch, features, revolve boss base. I've only got one axis. It assumes I want 360 degrees, which seemed like a good idea. So now I'm good. Now let's do the cutout. Sketch on this face. Make me a center point rectangle. Maybe. Alright, there's my cutout. Need 2 dimensions. For WR32, that looks like a C, which would be 42. And this guy here is a D, which is 1/4 of an inch. Yeah, that wasn't too painful. Why is this thing hitting here almost? Because I chose the wrong number. Let's get out of here. If you'll notice on the callouts on the drawing, there's a different diameter for those two outer diameters. I call it OD1 and OD2. And so I need to fix that. So you'll have to pay attention closer than I did when you make your sketch 1. This is 625 in my case, and this one's 625. I call these OD1 and OD2. We'll turn these parametric on the going from a good to a great model to make it so we can build all of these things. But for the first go around, just make your part match whatever one you've been assigned. Alright, so when I do that, get out of that sketch. Now my other sketch looks more reasonable. I need to do an extrude cut. Need to go all the way through the part. That's my design intent. So now I'm going with that. Now I'll make my hole pattern. I'll start with these counterbore tapped holes. So I want to start with a hole wizard. These are 440 tapped holes. So I'll choose such I want these to go through all. I want to use cosmetic thread, thread color, thread class. All that looks good. Now I want to go to positions. I want to select the face, and I'm going to click 1, 2, 3, 4. Unfortunately, it won't let us do tapped counterbore holes, so we're going to have to do the tapped holes first and then add the counterbores. Since I just randomly clicked on the screen, I got to go in the sketch and tie down the locations. So I'll line those up vertically. Seems like a good idea. Line these up horizontally. Missed that, didn't I? Get rid of that. Go back and get that point. Line those up horizontally. Now I might want to use construction geometry to control these guys. So if I select that and make that construction geometry, and I can click this, control click this and make it coincident, but I'm lazy today, so I think I'll just drag it over there. So if I drag that point to the circle, I'm patient enough and wait for the thing to catch up. I can drag this point to the circle and get my coincident constraint. That seems like a pretty quick way to do it. So if all of these points live on the circle and they're all lined up vertically and horizontally with one another, then all I need to do now is put a dimension for this DBC. DBC is diameter bolt circle. So if I dimension this construction circle and make it 0.9375, now I should have a fully constrained sketch, which I do, and then my holes are actually located where I want them. Now it's time for the counterbores. I'm going to go make a sketch on the same face. I'm going to draw 4 circles, and I'm not going to dimension to these circles. I'm going to locate them to the existing circular features. So I'm going to hover over that circle, go grab the black circle. Now that circle has already got that built-in constraint to be coincident with the other edge. Don't click, just hover. Get the black dot, go get it, place your circle. Hover over, get the black dot, make your circle. One more time. Piece of cake. That one's not a piece of cake because I missed it. Let's try it again. 3 out of 4 is not bad. It's not perfect. There we go. Now all of them are sitting at the coincident. Now I can select these and make these all equal because I don't want to put 4 dimensions on here. That would be silly and a waste of time. Now I just need one more dimension. And should have a fully constrained sketch. Get out of the sketch. Select the sketch. It's playing that trick on me again. It says minus there, but it should be fully constrained. See what it says when it gets out. There it goes. Fully constrained. Pre-select the sketch. Features. Extrude cut. And I want to go... How deep do I want to go? I forget how much it is. Whatever the drawing says. Alright. It's a beautiful thing. Why am I not seeing my tapped holes? Well, because I got to change these silly settings. I come down here and turn on annotations. There they are. Cosmetic threads look beautiful. Alright, so add your material. Oh, we're not through yet. We got to add these pin holes and clearance holes. So, spoke too soon. So let's add those guys. Again, I want to do a diameter bolt circle. Help control these things. Make me a construction circle. And I need two different size holes. I need a hole here and a hole here. And a different size hole here and here. And how am I going to locate these things? Well, I don't have two dimensions, X and Y. I've got a diameter bolt circle. I got some angles. So I don't want to have to do any trig, sines and cosines to figure out the X and Y distances. So let's do something more reasonable. Let's define the bolt circle, diameter. Diameter bolt circle. And let's do some more construction geometry. I love construction geometry. So there's a line. I'll connect this guy to this guy. Right click select. Should have said in chain. Another one from here to here. Right click in chain will keep you in the line command. Select will get you out of the line command. So I'm going to turn these into construction geometry because they're not part of my extrude shape. They're just part of what I'm using to control the geometry with. And so I want to select this line, control click this line, get them both at the same time to be construction. And if these are diagonals, I got to have these go through this origin. So I want to select that line, control click the origin, coincident. This one also needs to be coincident. Now those lines are all going through the center of the part, so I know their diameters. And now all I need to do is add a 45-degree dimension. These are all controlled like I like them, same with the other ones. So I want to make these two lines. I could do a 45 and a 90, but I like construction geometry. Let's make those perpendicular to one another. And then all I need is, what the heck happened? How do I dock that back where I want it to go? That's kind of a pain. Somebody get extra points if you can tell me how to get that docked again. So now I want to go to dimension. If I could just find the button. From here to what? There's nothing, there's no horizontal line to dimension to. Well, there is. Don't forget about your planes. And so I can dimension from that line to the plane and make that 45 degrees. So now that sketch is constrained except for the size of the holes. So this guy here needs to be one size. Hope I get these right. Check the drawing. This may or may not be right. This one's going to be the other size. Whatever that number is. Alright, what's happened to my sketch? It looks like it's underdefined. It says, why is it underdefined? Haven't made these equal yet? Is that my problem? This guy and this guy need to be equal. Don't leave me, Maverick. That circle and that circle need to be equal. this circle needs to be equal. That's got to be it, right? What's left? Fully defined, just the way I like it. Get out of the sketch and pre-select the sketch. How in the hell am I going to get back to the command line that I want? Features, extrude cut, through all. Alright, now I think I'm done. So don't forget to add your material. You go make the part, the little pin part will be next. I'm not even going to show you how to do it, it's too simple. MS16555, go find the pin. It's the correct size. It's 1/16 inch diameter. It's 5/16 inch long. It's made out of stainless steel. Go find the right standard. Call it a MS16555-XXX, whatever the part number is. Use that as a file name. So when we do our drawing, all those file names will populate as part numbers in the BOM. So that looks like it for now. Now we'll move on and turn these good models. Well, first thing we'll do is make an assembly model. And then we'll turn the part models from good models to great models. And then after that, we'll turn the assembly model from a good model to a great model. And then we'll spend about 5 minutes making a drawing. All we're going to do is push a button to say make the views, another button to show the dimensions, another button to put in the BOM, and another button to do the balloon. So 4 buttons, we'll get the whole drawing, we'll do that. That'll be step 1, 2, 3, 4, 5 or so. So anyway, that'll be all for now. Thanks for watching, and we'll see you on the next video.